Hello, and once again, welcome to the second class on thermodynamics for beginners. There will be a little discontinuation from this class. We'll be resuming the third class in the coming week, not in this week. We are heading for a weekend and we are staying in US. So weekend is very important. So maybe we'll be having class on coming Tuesday. I will talk about that and I will notify. And you guys who are watching from the YouTube source directly have a watch on our website, uh, theuranium.in, www.theuranium.in. I'm giving the links, the YouTube links there. So let's start. Uh, we are starting half an hour before, and also we'll be having a 1 hour class today, not as usual 2 hours class. So let me share my screen and straight away come to this is 2 and I am. Can you see my screen? No?
Yes, sir.
Question number 10 and 11, can you see?
No, sir.
So that is why I have, shared a different screen. I think I will. Can you see now?
Yes, sir.
No?
Yes, sir.
10,
We can see now.
10 and 11?
Yes, sir.
Okay. Ohm is missing. Anyway, we will go for the second session. Welcome, everyone. This is SS Tripathi. Oh, I'm writing welcome. Thermodynamics. For beginners, lecture 2. Here is a question by one of our students, Rudra, to further elaborate on the state functions and intensive and extensive property. I told you those functions which are called state variables or state functions which are path independent. So out of this is a question set in 2009 in IIT JEE asking which one of these are or is a state function. That means it is independent of the path. I told you that accepting work and heat, these are the two which are path dependent. Whether you go this way or this way, there will be difference in the amount of heat absorbed or evolved or the amount of work done or by the system or on the system. But there are restricted conditions where the work done as well as the heat transferred might be a state function, but usually they are not. We'll talk about that today. So undoubtedly U definitely, and this is H. So these two are the correct answer. Enthalpy or molar enthalpy doesn't matter. Whether it is enthalpy or molar enthalpy, but only enthalpy is an extrinsic or extensive property. Molar enthalpy is an intensive property, but here the question doesn't ask about intensive and extensive, asks about state function. So whether it is only enthalpy, which is size dependent, or molar enthalpy, which is size independent. 1 mole means 1 mole. So they are not dependent on path through which the initial state is, final state is arrived from the initial state. Is it clear now, Rudra?
Yes, sir.
Now, the second question he asked, out of these, which is or are intensive properties? Welcome, Omkar, you are late. When intensive property or intrinsic property, which are mass or size independent, like temperature, pressure, surface tension, viscosity, density, refractive index, all these things. Now, out of this, we are having heat capacity is mass dependent. Had it been specific heat capacity, it is mass independent, intensive. Resistance, R is equal to rho L by A. So it depends on the mass, size, and all that. So we are left with molar conductivity. Since it is molar, whether you are having 1 mole from here, from the entire bulk, or from there, so molar conductivity is an intensive property. And also EMF, you have little knowledge about, because you are mostly class 11 student, you have a little knowledge about EMF. That will be discussed in a class 12 program. Those who are watching belonging to class 12, EMF of a cell, it doesn't matter whether you are taking a small portion of the electrolyte or large portion of the electrolyte. So it is not dependent on that, whether it is standard EMF or EMF at any condition. Once you have prepared the cell, the EMF is fixed independent of how much of the electrolyte you consider, or how much of the electrode material you put. But the difference between the oxidation half cell and reduction half cell, which is the what we call the cell EMF. EMF is a misnomer. It is the potential difference of the cell. Cell potential difference is called the EMF, out of which some part of it is being vested inside the cell because of the internal resistance, and the rest part. And if we consider the internal resistance to be 0, then whatever voltage the source of EMF or the battery is supplying, all is being enjoyed by the external socket. Oh, I'm coming to electricity. Forget about it. Now we shall be continuing from where we started. The first law we started. I have a question for you. In which case the work done is greater? The guys who are watching from the YouTube, good evening all, and you also can write down the answer in the chat box, whether the work done in a slow reversible manner in an expansion process, you are expanding an ideal gas from a lower volume to a higher volume in a reversible process, very, very slowly, infinitesimally slowly. It's an ideal situation following the Boyle's law at a constant temperature. For example, it is an isothermal reversible expansion. So which work, this work is greater, or if you expand it suddenly under an external pressure, suddenly you relieve the high pressure that it was in to a very low pressure, so that the piston moves abruptly. Within a short time, it reaches its final value. Even then, the two initial and final states are same, but the amount of work done in the irreversible case, in the second case, and the reversible case, which work is greater? Yes,
Sir, in reversible processes, it is greater.
Precisely correct, because if you draw a P versus V graph, this, whether it is expansion, you are going from V1 to V2. If it is compression from the same V2 to V1, then you are going in this direction. This is compression, this is expansion. So the area bound by the graph, and what is that value? Can we tell me when we integrated? I think you have this general knowledge, although officially you have not been taught about integration, some of you who belong to class 11, but you know the area bound by a graph, the integration of certain for example, this is y coordinate, this is x coordinate, and y is a function of x, for example, is some function of x is y. So you integrate this function of x with respect to dx with certain limit, supposing say some x1 to x2, some limit, then the value that will appear, that will be what? Yes, anyone who can tell me what is the integral value of y coordinate integrated over a certain limit, lower limit to higher limit, with respect to the dx, that is the x coordinate dx. What is that, Rudra? Oh, that means you have not yet studied integration.
Sir,
And I
integral.
think we had discussed in our class 9-10 program, we had discussed taking a small dx, a small thing, a small this thing. And when this dx, this is a y coordinate, y coordinate, and this is the x coordinate change. So this fx is the y coordinate, and this is dx. So this is the small area when fx into dx. But since it is a curve, it's not a rectangle, then the integration will help us, not the finding of this small rectangular area. So that will give us this area will not, because the small little portion that we will leave every time, this will not be got if you add the rectangles or areas of the rectangles. Only when you integrate any function, a curve, any function over these v1 to v2, then only you will get the entire area bound by the graph. So I'm really surprised, Rudra, you are not able to know that integration of any function, say p is here, is a function of v, and you have integrating this graph, this function, and in our case, we expressed, we expressed, uh, this one. nRT was outside, minus was outside, W reversible, nRT was outside. We were, this is 1 by V dV. 1 by V is the y coordinate, fx. This is dx. 1 by V is the y coordinate, which is a function of x, V. So we are expressing pressure as a function of volume 1 by V, but these are constant terms. Isothermal we have segregated outside. So this is equal to how much?
Sir, ln of V2 by V1.
Yes, if you give the limits, it will be ln V, and if you take the difference, it will be minus nRT ln V2 by V1. That we know. So you are not able to So this is the irreversible work done. Graphically, geometrically, it is nothing but the area bound by the curve from V1 to V2. This is a curve, not a straight line. Boyle's law curve. And this is nothing, the area bound by the graph, because the principle of integration is to find the area bound by the graph, which is expressed y versus x, y as a function of x, right? So this area is more than, who can tell me what is the irreversible work done? What is the formula for that? We are joined by few viewers from the YouTube directly. Hi there. Yes, what
Sir,
is? Tell
Sir,
me.
minus P,
minus Sir,
Yes,
minus P external upon B final minus B initial.
or simply P external into delta V. So if it is expansion, as you know, that we are carrying out the expansion under a lower pressure condition, supposing earlier it was on 20 atmosphere, the expansion is happening under 1 atm, and so here it will be the area bound by this rectangle. This into this means this is 1 atmosphere, the external lower pressure under which the expansion is happening, and this delta V. So P delta V is the area of the rectangle. So minus, you know the reason why in chemistry we always put a minus sign for work, so that expansion work will be negative, compression work will be positive. That is why. So definitely, but what about compression? When I just change the expression, I mean from expansion to compression, you are going from V2 to V1 in this way. So then you are carrying out the compression work, if it is irreversible, fast, then under 20 atmosphere. That means the area of under this rectangle. But the reversible work is same. This is expansion work in this direction, the compression work in the opposite direction. The expansion work is negative according to us, I mean chemical convention, and the compression one is positive, right? But the compression irreversible work is going on at a higher pressure condition. The constant pressure is higher, 20. So it is taking a great load while it is compressing. So it will do more work. And I will explain to you what will happen. It has to dissipate some heat to the surrounding. It can't consume all, because system and surrounding, they are very sober fellows. They are very good fellows. They will not be happy unless they give you a return gift, not the same thing that you give in a different form. I used to, in a very lighter vein, let me tell you, when somebody brings a sweet packet to our house, sweet packet, right? Usually, what I find that the host does not provide the same sweet that the guest has brought for you. Either they keep new sweets, I mean, other sweets beforehand, their sweets, which might be different from the guest sweets, or something else the guest prepares for the host. I mean, the host prepares for the guest. But I am in a habit of, opening this sweet box, mithai ka box, sweet box, in the face, in the presence of the guests, and serve them. Of course, my better half is not happy about this, but I'm very happy, because I always have some eye on the sweet I used to take to my guests. to my hosts. So I didn't eat in the in the sweet shop. So I have an eye. So I wanted to eat. And if somebody else, the host will give a different sweet, then I'm lost. So I'm just kidding you, because why I told, because we're going in the same direction in reversible, but in irreversible compression, we are under a greater load. Yes, some part of that work done will be definitely, lost as heat to the surrounding. We'll talk about that later. When you solve many more problems, your ideas will be more and more clear. Now, coming to enthalpy now. We'll be talking about, oh, sorry, this is thermochemistry. We have nothing to do now. At this point of time, we know that del E is equal to the rupee plus dollar. In any form, you can increase the internal energy. With proper sign conventions in chemistry, we can handle any problem of thermodynamics, first law. So now we know if the work done is irreversible, so in place of W, if it is done under constant pressure condition, usually a reversible process is a misnomer, is just an ideal example before us, just to compare how far behind we are from the ideal value. But the reality, we are very fast in eating, and fast in doing work. So if it is irreversible, then what I will write in place of W? Yes?
Minus P external into V final
Yes,
minus
precisely,
V.
minus P delta V. This P stands for the external pressure. So if we just bring in and make a rearrangement, Q becomes equal to what? Yes or no?
Yes, sir.
Yes, yes,
So
sir.
you keep this just for 1 minute, you just keep it. You will come to the enthalpy after some time, and you will see how this equation will be correlated with the enthalpy expression that was defined. Now, before that, I would like you to copy this problem quickly, because this will be a 1-hour class. For some reason, for my personal reason, we will have restricted time today, 1 hour, maybe 1 hour 15 minutes. So guys, please bear with me, otherwise I never budge an inch before 2 hours. And I try to keep those who are with me either directly or in the YouTube glued with me. Of course, if they are really passionate about learning something from us. If just for fun you are watching, then you will be leaving, this YouTube video within few minutes. You will leave, as people do. They watch hundreds of videos, but for 1 minute or half a minute. But very, very limited number of guys, they are glued with the video things, if they are passionate to learn something from the video. So guys who are outside, please write down this problem, use a pen and paper whenever you are watching, whether live now or sometime after. You write down this problem in your copy. We'll be solving this problem, and then possibly we shall be living. But we will compensate, because a lot of things are there. Minimum, it will be a 15 to 20 hours program total, including the higher level aspects and hardcore problems set in IIT Advanced, both in physics and chemistry. We'll be solving all problems from any source, physics, chemistry, whatever you get, you can ask me, and maybe you can answer of your own once you take my course in thermodynamics. So, written?
Yes, sir.
Okay. Then try to use your calculator and solve the problem. Calculate the work done in respect of 1 mole of an ideal gas in a piston fitted cylinder. In a piston fitted cylinder, at it, the initial pressure was 24.83 atm and 300 Kelvin, that means 27 degree Celsius, to expand to 10 liter. We don't know what is the initial volume. We can use PV is equal to nRT to find the initial volume. At the same temperature, this is isothermal, that means. So first of all, find the initial volume, that is very much required here. Use PV is equal to nRT to find, the initial volume. So V initial will be equal to nRT. N is 1 mole, R is 0.082, temperature is 300, Y, the pressure was very high, 24.83. So what is the volume? Be quick. Be quick in your calculation. Use, because this is a YouTube video, and
Sir,
yes.
so 0.997, approximately
So
1.
let us make it 1 liter for our calculation. 0.997 liter, Miss Samidha. Let us make it 1 liter, right?
Yes, sir.
And that means the initial volume was 1 liter. It was expanded to 10 liter. Let us read point number 1. If the external pressure is reduced to 1 atmosphere in a single step, now tell me, if it will go from 24.83 atmosphere to 1 atmosphere in one step, what kind of process is this? Reversible or irreversible?
Sir,
Irreversible.
irreversible.
Obviously
Irreversible.
irreversible. Then find out what is the work done. Calculate the work done. In every case, you have to find the work done. So work done beat 1 is equal to minus P into delta V. Minus P, P is what? Who can tell me what is P?
24.83.
Are you kidding me? Are you kidding me? In expansion, the work done against the lower pressure under which it is
Sir,
expanding.
sir, 1 atm, sir.
Yes, it is
Okay.
1
One.
atm. You forgot that 24.83 is gone over from its head. It is now working under a low pressure 1 atmosphere. So the external pressure under which the expansion occurs is the lower one, not the higher one. So 1 atm. And what is the change in volume? It was 2 previously, and now it is 10. So final volume minus initial volume. So what is the value? This is liter. So this is 8 liter into atmosphere. Now convert it into
Sir,
joule. Let us remember a
sir,
conversion value. 1 liter atmosphere is equal to 101.3 joule. Remember this. You can also convert.
sir, sir, delta. Sir, it was 1 liter initially.
Oh, 1 liter. I'm so sorry. Not 2 liter. I'm so sorry. This is 10 minus 1. Initially, it was 1 liter. We have found out here. So 10 minus 1 is 9. I'm so sorry. So 9 liter atmosphere. And remember this conversion formula. 1 liter atmosphere is 101.3 joules. You can convert yourself. You can convert yourself. You will find it is 101.3 joule. So how many joules then? 9 into 103,
Sir,
101.3.
900. The
900
911.7.
joules. Now look to point 2. If the external pressure is reduced to 5 atmosphere in the first step and then to 1 atmosphere in the second step, that means a single step is now split into 2 steps, and by that you have to find the areas of the rectangle 2 times. I mean P minus P delta V you have to find 2 times and then add to find the total work done. So now you find out when it is 5 atmosphere, what is the volume you have to find out, because it was 1 liter in the beginning, uh, 1 liter in the beginning, and at 5 atmosphere, what will be the volume that you have to find. So again you have to find out PV is equal to nRT, and V new volume at 5 atmosphere is 1 mole, 0.082 into temperature is always constant, isothermal process, by P. P is 5. So what is the volume? This is V2. This is V2. This is V1. Is 1 liter. V2 is how much?
Sir,
Guys who are watching,
4.95.
huh?
Sir, 4.956, approximately 5 liters.
4.956. Let us approximate it to 5 liter for the sake of numerical understanding how you can solve the numerical. Let us condense it to 5. I mean that let us abbreviate to, approximate to 5 liters. Now tell me what is the work done in the first step and then second step. We have to find separately. So it is looking clumsy now. I am adding this thing. So work done in the first step when it was brought from 1 liter to 5 liter at a constant pressure of what? Who can tell me? The first work done has been achieved at a constant pressure of what?
5 atm.
Obviously 5 atmosphere now. The 24.83 load has been replaced by 5 atmosphere load. So it is expanding under the external load of 5 atmosphere. So let us find out W1 is equal to minus P external into delta V. That is equal to minus 5 atm. So the volume is 5. The final volume is 5. Initial volume was 1. So how much?
Sir, minus 20 atm liter, which is equal to 2 minus 2026 joules.
Minus how much?
2026.
Then we have not yet found out the second step. Then 1 atmosphere load was given. So the second was from 5 liter to what was the final volume? Final volume was 10 liter.
Liters.
10 liter. So from 5 liter to 10 liter. Now tell me what is the constant pressure under which it is expanding. It is given.
Sir, 1 atm.
It is given after 5 atmosphere load. Whatever expansion has happened, we have known it has expanded to 5 liter, from 1 liter to 5 liter. And then we remove the 5 atmosphere load and then put immediately. And there are so many, and I'll show you how they do to increase the number of steps. So we remove the 5 atmosphere load and put 1 atmosphere load. Say then what is the work done? W2 is equal to, I don't have space, is equal to minus, it is constant pressure is 1. So 1 atm into what is the volume difference? It was now 5. So it was No, it will go to 10. 10. 10 is the final volume and 5 is the initial volume for now. So what is liter atmosphere? How much liter atmosphere?
Sir,
Tell
5 liter
So
atmosphere.
5
5 liter
into
atmosphere.
1. 10 minus 5, 5 into 1, 5 liter atmosphere. So tell me what is the, so W2 is minus 5 liter atmosphere. So 5 into 100, 1.3 joule. How much?
Sir, minus
506.3.
506.5.
500?
6.5.
All are negative work. Expansion work, according to our convention, is negative. Compression work is positive because work is done on the system is positive. Expansion, the work is done by the system is negative. So total becomes W1 plus W2. So minus 2026 plus minus 506.5. How much?
Sir, minus 2532.5.
Yes. See what a difference only by, making it in 2 steps instead of one. One step, the work done was only 911 joules. We have found out here. Here. And in only 2 steps, the work done, total work done has become this much. About 2.5 times more. Then the question will say, then find out the ideal value. If the gas expands reversibly, infinitesimally slowly, then what will be the work done? Then you have to follow the integrated formula. What is the integrated formula for that? Who can remind me what is the integrated formula to find the reversible isothermal work done?
Sir, minus nRT ln
So let us
V2
make
by
it
V1.
2.303. Then it will be
Log
log.
V2 upon V1.
We have also pressure data. Pressure was 24 point something initially and finally it is 1. We have also volume data. Whatever you can use now in this question, you can use any data, we get the same answer. Number of moles is 1 and this is 0.082 into temperature 300 into log expanded from, final volume was 10, initial volume was 1. We have found out 0.99 something, we have taken it as 1. So log 10 is how much? Log 10 to the base 10
1.
is 1. So calculate this and convert. This is liter atmosphere. No doubt we have taken volume in liter and the R is liter atmosphere. So this ratio will cancel. So, but R is liter atmosphere. So the answer will be liter atmosphere. Per Kelvin will cancel. Temperature will cancel. So we'll be left out with liter atmosphere. So how much?
Sir, 570.68.
Liter atmosphere. Convert it into joules.
Sir, 57.8 kilojoule.
50 ନା ଆଗ କୁହ କେତେ ଜୁଲ କୁହ?
Sir,
5 57
57,810.22. 22.
now see, how can we have this? What is this one? Where is this? This has come from. It's not being. Okay. So now see, 5 57,810. It's much greater than this. This is only 2,500. This is only 900 something, but the reversible work done is so high. Are you correct in your calculation? Is it 57,000?
So mine was coming 566
Of
point
course,
something
minus,
ATM at
I am missing the minus sign, okay? Minus, okay? That I am missing. What you are getting?
So minus 566 point something.
This one.
Yes, sir.
Okay, let us ignore that. But into 101.3, it becomes how much? Is it Rudra 57,000?
Yes, sir.
अब पानी के पानी मेरा भी कैलकुलेशन है यहाँ मेरा भी कैलकुलेशन इधर है you can have a look. Yes, 912 approximately. The one step process, two step process. Oh, I was annotating here. It is minus 2492. What we have got? 2532. My calculation is approximately. No. Yeah, total. Total is I got 2492. Doesn't matter. I have, and yes, no, it was 5,738, not 57,000. You are wrong. You calculate once again. 101.3 into 56. And ohm, did you get this value 56 point something?
No, sir.
Then,
I was getting 566 point something. One decimal place went right.
oh, right. Here we get 9. Here we get 24.6. And here we should get 56. No, you have done wrong. You have done wrong in the calculation. 2.303 into 1,
Yes, sir.
1.082.
Yes.
Yes, sir.
अब I,
Sorry, sir.
sorry, sir. मुंह भूल कर I have done a great mistake by writing 0.82. That is the serious mistake that I had committed. Here I have written 0.082, but here I forgot. Everywhere I have written 0.082, but here I forgot, and you were swayed away by my slip of pen 0.082. That is why, Samidha, you got a wrong answer. It should be 57 point. Oh, I am having some difficulty, doesn't matter. Correcting here, 57 point something. So it will be 1 0 less. Understand? One decimal point to the left. 5,780 something. Got it?
Yes, sir. Yes, sir.
5,000. So definitely it is greater. The numerical value is much greater, nearly two times greater than two-step process. If you make in 3 steps, still it will be more than 2,500. 4 steps, as many number of steps you increase, more and more steps you perform, then you will be heading towards the ideal value. But you can't exceed the ideal value. This is the maximum work that you can generate out of this expansion from 1 liter to 10 liter, from 24.83 atmosphere to 1 atmosphere. The maximum work done is 5,700 some odd. Understood?
Yes, sir.
Yes.
Now I will be introducing very quickly about the enthalpy. It was introduced from enthalpy change. It was defined the scientists introduced a new parameter. I will tell you why and how. The enthalpy change is the heat absorbed or evolved at constant pressure. So change in enthalpy. So this enthalpy, it was given a term H. U was for internal energy, H is for enthalpy. It was found, interestingly, listen to me, what led the scientists to introduce a new thermodynamic term called enthalpy, because they found if they carried out any expansion compression process at a fixed pressure condition, usually even chemical experiments, physical experiments, they're done under 1 atmosphere condition. When the pressure is remaining constant and you are performing some expansion compression process or any physical or chemical change that you are performing, they found that if the system absorbs some heat from the surrounding, it is not consuming all the heat that it is absorbing is not responsible to increase its internal energy. Rather, the increase in internal energy is smaller than which is expected of the heat absorbed. Why? Because some amount of heat it absorbs, it returns back, a return gift it is giving back to the society, I'm sorry, to the uh, surrounding in the form of work, in a different form. The guest uh, brought Rasagulla. Bengali people who claim that Rasagulla was their creation, they pronounce as Rosagulla, but the host gave Gulab Jamun in the form of, they received a lot of Rasagullas. Internal energy increased, no doubt. Out of that, they had a magic to convert that Rasagulla to Gulab Jamun and return in the form of work. Never they found under constant experiment, constant pressure experiment, they never found that all the heat is involved in the increase in internal energy. Part of the heat was definitely gone as a return gift. Similarly, when the heat was evolved out of the system, then the surrounding cannot also enjoy all the rasagullas. They will convert a part of rasagullas into gulab jamun's work. So work will be done on the system. So then they found, and if that is the case, then so why not we introduce another term so that enthalpy, that whatever heat is absorbed or evolved, we make it QP. P stands for constant pressure. That is equal to the change in another parameter called enthalpy. Why? Because when the volume was constant, you take a sealed container, not with a movable cylinder, sealed container, ढक्कन को बंद कर दो, very tightly you ढक्कन को close कर दो. That case, they found whatever heat was absorbed or evolved, they were responsible to only change the internal energy, no return gift. Because झरका अगर खाली, हिंदी में बोल दिया, if there is no room for expansion, pressure variation, so you close the door, no doubt, but allow the air to come. I mean, just kidding. Air means matter. I mean, put a movable piston so that there will be room for expansion compression. It will be under the care of the external pressure, maybe 1 atmosphere. So in that condition, they found that there is return gift, not under completely sealed condition, no return gift. Everything was gone. That is why they introduced another thermodynamic property. Now, I bring your attention to this one. So when the pressure is fixed, constant, external pressure which is constant, so this can be called QP because the external pressure under irreversible condition. So del H, which is now called QP, is equal to del U or del E. Did I write del E? Because I was for long years I was in a habit of writing E. Now in the last couple of years I have changed my habit to U. So del U plus P del V. So H2 minus H1 is equal to U2 minus U1, change in internal energy. Again I am writing E. Galti se mistake. Plus the constant pressure P into V2 minus V1. So if you make a rearrangement, it will be coming that, what? H is equal to U plus PV. This H U PV2. So if you compare, this is H2 minus H1 is equal to U2 minus U1 plus PV2 minus PV1. So if we make a group, H2 minus H1 is equal to U2 plus PV2 minus U1 plus PV1. So that means the absolute value of enthalpy HH will be equal to the absolute value of internal energy plus the absolute value of PV energy. So the absolute enthalpy, let me tell you, neither the absolute enthalpy nor the absolute internal energy can be determined by any experiment in the world, but their changes can be determined. So, but we can define, just theoretically, we can define what is enthalpy. Just like we defined theoretically, it is the sum of all types of energy, all types of potential kinetic energy, excepting the PV energy. Now the PV energy has come. So the absolute value of enthalpy or simply enthalpy, this is internal energy. We call the enthalpy is the sum of internal energy and PV energy. All these are theoretical, nobody can measure U and H. So how to say what is PV energy? It is theoretically, it is the amount of energy that a gaseous system spends while existing in that space. To create a space for its existence, to create pressure and volume, it needs some energy. That is the PV energy. The energy of the gaseous system. To make room, make space, make room and make space in the environment, in the surrounding, in the environment. To exist and create its pressure and volume and occupy some volume. These are all theoretical. But we know that some energy term is left out. That we scientists called PV energy, and they defined PV energy as the energy that it is spending for its own sustenance, for its own existence. But it carries no physical significance because we don't measure PV. Of course, if you multiply the actual pressure exerted by the gas and its volume, you get a value PV. That will be the absolute PV energy of the system. But we are not interested in that. We need P delta V. Then only that will give you del H. If del U is known, or if del H is known, you can find del U. So let us now proceed, because we are, so that means QP, which is equal to del H, is equal to del U plus P del V. So when there is, when del V is equal to 0, sorry, del V is 0, there is no change in volume. In that case, it will be, QP will be called QV, which is equal to only del U. QP will not be called QP now. Only when it is done at constant pressure, as there is some volume change, then we call it QP. Then if there is no volume change, volume is kept fixed. So we forget about pressure. We write it that it is the heat absorbed or evolved at constant volume, and that is nothing but equal to a change in internal energy. So we can define, del H as the heat absorbed or evolved, which I have already written, or evolved at constant pressure. And now we shall write another definition for del U. Del U, not U. U is theoretically defined as sum total of all types of energy. But I am defining del U is the heat absorbed or evolved at, who can tell me?
Constant volume.
Constant
At constant
volume,
volume.
precisely. And let me tell you, this del H, which is equal to QP, is experimentally determined by a specific calorimeter called constant pressure calorimeter. This is specific calorimeter. Calorimeter, or it is also called isobaric calorimeter. And more technically, it is called differential scanning calorimeter, DSC. And this del U, which is equal to QV, is determined from constant volume calorimeter, which is called adiabatic bomb calorimeter, bomb calorimeter. We'll explain later what is that. Or isovolumic, or simply constant volume calorimeter, which is called adiabatic bomb calorimeter. Why bomb? Because the volume remains constant and you develop more and more and more and more and pressure, then a time will come when it will explode. That is why a constant volume calorimeters are often funnily called bomb calorimeter. Be careful, don't go for very high pressure, which these apparatus cannot sustain, cannot tolerate, and it will explode. So constant volume calorimeter or bomb calorimeter. Now, so far, now if Miss Samidha, if you have class, you can leave and you can watch the last portion, right? Priyani, what a pleasant surprise. Okay. I think another 15 minutes I will finish. Let us apply whatever we have learned so far for a chemical process where a chemical change is happening. And we have quite a sizable number of viewers watching directly from the YouTube. Hi, how are you liking? What is going on? Is it benefiting you? If you are a student and you are a class 12 student or even a revisioner, and if you have some weakness in thermodynamics, then I assure you, you follow me or attend all my classes with pen and paper, and at the end you will yourself say that I am able to now solve any problem that I am given, whether in physics or in chemistry, whether in IIT mains or IIT advanced or NEET, whatever. Chemical processes. Supposing we are carrying out a chemical reaction where supposing a gaseous reaction where supposing XAG plus Y B, supposing this is a solid, gives rise to is a P C, supposing this is a gas, and supposing Q D, it is a liquid. This is a chemical reaction that is happening. Let me not write the reversible sign. So when I want to ask you that what is the change in the number of moles per reaction, that we have represented in a balanced equation. So change, that is the change in the number of moles of only gaseous components, only. So tell me what is delta N here, because we are applying the first law process to the gaseous system, because there is no change in volume when solids and liquids are involved. If all the reactants and all the products are either liquids or solids, then the volume change is negligible. We say del V is 0. But whenever there is a gas, either in the reactant side or product side or in both these sides or all of them, then there is a significant change in volume that will happen if it is carried out under constant pressure condition. If you darken, if you close the container, seal the container, then del N, change in number of moles has no meaning at all. So now tell me, what is the change in the number of moles?
P
Sir,
minus
X
X.
plus Y minus P.
No. Always change is the final number of moles, total number of final state minus initial state. What was the number of gaseous moles in the final state? Gaseous, I repeat. This is
P minus
liquid.
X.
The liquids and solids are to be disregarded. Their change in volume is negligible. So only you have to pick the gaseous component. So in the final state, that is in the product state, it is what? What is the coefficient?
Sir, P.
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 And in the reactant state, it is
X.
X.
So P minus X will be taken as delta N here. So we'll be telling, for example, calcium carbonate is decomposing as calcium oxide solid and carbon dioxide gas. So what is del N here?
1.
1 minus 0 is equal to 1 plus 1. But if you take this reaction where all are gases, so you have to take all of them into account. What is del N in this case?
2.
What 2? What 2? What 2? Plus 2 or minus 2?
Sir, plus
Minus.
minus 2.
Then why did you say final minus initial? This is the product is final 2 minus this is 1, this is 3. So 1 plus 3 is 4. So that is minus. So it is to be minus 2. So and for example, this is the gas. Sorry, this is the reaction H2 plus I2. Both are gases, giving you 2HI. In this case, what is del N?
The 0.
It is 0. 2 minus 1 plus 1, 2. So it is 0. So del N If it is 0, then there is no volume change, because PV is equal to nRT, pressure remains constant, then and T remains constant, then P del V is due to the change in the number of moles. If there is a change in volume, then it is due to the change in the number of moles that is happening during reaction. It was previously 3 moles, now it is 5 moles. Then 1 mole extra is generating, doesn't matter whether dubla or patla, that is a thin guy or a bulky guy, doesn't matter. It matters how many number will be hitting. So more the number of moles produced, and if you keep the pressure constant, keep the piston under the care of a constant load, for example, 1 atmosphere like this. Here only 1 atmosphere is there. You are not putting your hand, or a constant 5 kg weight is being put. So 5 kg plus 1 atmosphere, that is a constant load it is carrying. Then the piston can go up, can come down, depending on what is going on. If the more number of moles will be produced, the volume will be definitely more to keep the pressure constant. To keep the external pressure equal to the internal pressure, the volume has to be more, because more number of guys have come up inside. So had the volume been same, then the force will be more, force per unit area would be more, pressure would be more. To relieve the pressure, to equalize the pressure with the outside pressure, which is less, it has to expand, it has to undergo expansion, so the volume will increase. Similarly, if the number of moles will be reduced, then the pressure will be reduced. But we want to have the outside pressure same as inside pressure to make the pressure constant. Then compression will automatically happen. How long? Until the outside pressure becomes equal to the inside pressure. Are you guys understanding what I'm saying?
Yes, sir.
Yes, sir.
So,
Yes, sir.
so the first law that we have written, QP is equal to del H is equal to del U plus P del V. So in its place, we can write, in place of P del V, what can I write? What can we write for a chemical reaction? If it is isothermal,
The delta N RT.
Sir,
precisely
delta
del
N
U
RT.
plus del N RT. So when we solve a problem on a chemical change at constant temperature and constant pressure, but chemical change is happening, number of moles is either remaining same, or number of moles is increasing, or it is decreasing. In that case, you'll be, if you want to find what is the internal energy change, if the heat absorbed or evolved at constant pressure is given, then you can use this. Or if you want, if you have given what is the internal energy change, that means had it been done under constant volume condition, then this would have been the energy change, that is del U is given. You want under constant pressure experiment, if the number of moles are changing, definitely there is a difference between del U and del H. So you have to find del H from del U and delta N, that you will find. But if del N is equal to 0, if del V is equal to 0, this happens. When that case, del H QP is equal to QV, that is equal to del U. So this term is not used. Once it is constant volume, then we say the change is change in internal energy rather than change in enthalpy. Enthalpy will feel bad, उसको बुरा लगेगा. Enthalpy change आया है only when there is a pressure remains constant and there is some volume change due to expansion or compression, if it is a physical process. Or if it is a chemical change, then the expansion and compression might happen due to change in the number of moles. Pressure has to be kept constant. If the pressure is not, if the volume is kept constant, if the volume is kept constant by using a sealed container. So delta V is equal to 0 under these three conditions. In chemical process, del N is equal to 0, like H2 plus I2, all gaseous, giving you 2HI, all gaseous. Even if it is not a sealed container, it is a movable piston is being attached, even if it is not a sealed container, still there will be no change in the volume. The level of the piston will remain the same. And the other one, if all reactants and products are liquids or solids, no gas. So even if there is a change, the change in volume is negligible. We say whatever heat will be absorbed in such a system will simply change its internal energy. Nothing will happen, because there is enthalpy in this case is same as change in enthalpy in this case is change in internal energy. If somebody will ask you, what is the change in enthalpy in a chemical reaction which does not involve any gas? We'll say change in enthalpy is same as change in internal energy, and that is amount that is equal to the amount of heat absorbed or evolved. And the other case, sealed container. If you use a sealed container, क्या होगा? कुछ कर नहीं पाएगा. There will be development of more pressure inside, because you are not allowing volume to change, or less pressure. So pressure will change. In that case, we will be, we will be doing later. We will find how we can correlate between del H and del E in such a case where pressure will change. We will discuss that later. But for this, we will find immediately del H is equal to del U. So let us solve a problem. Just write down this problem. Now I have shown del N can be 1 plus, del N can be negative, and del N can be 0. This is overwriting of all this. I have also explained the three cases where del V will be equal to 0. Yes, you write down this. Yes, this problem. So here I have solved it, but doesn't matter. You write down this equation and see to yourself. Find del N for the gaseous components, right minus left, and it is asking if the heat evolved for the following reaction at constant pressure. That means del H is given, is 320. Evolved means minus. If in the question there is no minus sign, but written that it is evolved, you put a minus sign. Then find the heat evolved at constant volume. That means it is asking what is the change in internal energy. So indirectly it is asking, find out what is the change. What is the change in internal energy? So the reaction is given, benzoic acid is a solid, oxygen gas, carbon dioxide is a gas, and at room temperature, water is a liquid. It is given. So 7 minus 15 by 2, how much? Del N is minus half. Right minus left. Only gaseous component. So del N is minus half, and you use this equation, del U, make U for E. So del U is equal to del H minus del N RT. So you find out yourself, minus 320 and minus, because del N is minus, minus becomes positive. Half into R, because I have put it in joules, the R value here, because I have to find in in joules. So instead of liter atmosphere, I have kept the value of R in joules. There also you would have taken 8.3 instead of finding liter atmosphere and converting with the conversion value 101.3 joules is equal to 1 liter atmosphere. You would have also done directly in joule. So 8.3 को हमने किया kilo because this is in kilo. Since the data are in kilo, we wanted to find the answer in kilo. So I have converted 8.3 into kilo, 0.0083 into 298. So what value of internal energy change you found? Tell me.
Sir, I am getting minus
Thank you, Tanushree
307.
Sahu. Thank you, Tanushree Sahu, who has written, hello, sir, amazing class on thermodynamics. Oh, I'm so elated, so ecstatic about your comment. Thank you, Tanushree. I don't know, there are so many ex-students who are Tanushree. I don't know who are you, but whoever you are, God bless you. And that will give me encouragement to disseminate my experience with full throttle, full force. Yes. कितना आया?
Sir, minus 307.63.
307. I got 318 ohm.
So I'm doing, I'm stuck.
Sir, R. Sorry, sir, I have taken R value wrong.
No, it says 02, that is in liter atmosphere. It is 8.3 joules. I made it kilojoules. Or else you could have made it joules by multiplying 10 to the power 3. Again converted to kilojoule. So instead of doing that, I converted this 8.3 joules as kilojoules. So what is the
Okay,
answer
sir.
you got?
Yes, sir, now it's coming minus 318.176. I also made the
Yes.
same mistake.
Yes.
I was also making the same mistake.
Yes.
Yes, sir.
Got it?
Minus 318.76. Yes, sir.
Okay. We are missing Samidha, but I had planned to complete this. Samidha, when you are watching, will be watching later at a later point. I know you will be watching seriously. You will understand everything. Don't worry. Now, let us, after having understood the application, the first law used for simple expansion and compression and applied for a chemical change. If earlier we were writing QP is equal to del E plus P del V, the same, because it came from the net bank balance is equal to Q plus W. In place of W, we write minus P del V. Pressure remaining constant, mind you, pressure remaining constant. So we brought Q to this side and took this to this side. So in place of QP, we can write del H. Another change in another thermodynamic property, enthalpy, which is same as del E when there is no volume change. But when there is volume change, we are carrying out at constant pressure. You found there is a volume change, then del H and del E are not same. They are different. We found in this sum how much numerically, how much they are different. I'm showing you once again. How much different? It was 320, now it is 318. Numerical value. I'm not talking, minus stands for evolution. That means 320 kilojoules. Now see, what is the Rasgulla to Gulab Jamu conversion? If 320 kilojoules have been released by the system to the surrounding, then remaining, but the internal energy change has not happened to the equal to 320. It has happened to the extent of 380. So where about the 2 kilojoules? कहाँ गया वो 2 kilojoules, nearly 2 kilojoules. That amount of heat that has dissipated to the surrounding. Surrounding is a very cool fellow. It's a very good guy. It has definitely done some compression work to the system. It has definitely used that 2 kilojoules to bring about some compression onto the system. That is implied. We are trying to understand what might have happened. Since the pressure is always constant, then after some time it will attain equilibrium, no doubt about it. It will act. But immediately Rasgulla, all Rasgulla which has is given to you, and it has become lower in Rasgulla value by 320. No, not by 320. System has given back in the form of gulab jamun, but ultimately it is increasing the internal energy. Ultimate, target is internal energy, whether work or whether heat. Work is done with the difference of pressure, or if it is a chemical process, chemical potential, or it is a mechanical one, then mechanical gradient, I mean the height gradient, or if it is electrical work, electrical potential gradient. So only when it is a temperature difference, temperature gradient, the heat exchange, I mean the energy exchange is called heat transfer. But all they do the same thing, they increase the internal energy or decrease the internal energy. Okay, with this much, we will try within short time to know the different processes. First law applied for different processes. Number one, isothermal process. So since del H is equal to del U plus W. Now let us start from the very beginning. Bank balance is equal to, that is better. Bank balance is equal to dollar plus rho. So in isothermal process, temperature remains constant throughout the process. Whether it is expansion or compression or it is a chemical change, temperature remains constant by using by a device called thermostat, electronic device, thermostat. It is a bath containing water, but having an electronic thermistor, that is called thermostatic bath. Thermostat is a bath. All processes are carried out inside that thermostat. So infinitesimally small change in temperature will be countered by the thermistor arrangement, so that temperature every instant will remain the same. It will try to change the temperature by releasing heat or absorbing heat, but whatever amount of heat is absorbed, it will be removing that. The thermostat will removing that. Whatever heat is evolved, it will give. So that the temperature will remain constant. Now tell me, if temperature will remain constant, out of these three terms, what will happen to one of the terms?
Sir,
Yes.
E will be also constant.
Yes,
Internal
because
energy.
temperature is only related to E. If E remains constant, so what is del E?
0.
0. So in this isothermal condition, del E becomes equal to 0. So this is Q is equal to minus W. This is very interesting. Whatever heat will be absorbed, all of them will be converted to work. Expansion ho, if it is expansion, then heat has to be absorbed. Then whatever heat will be absorbed, iska internal energy change nahi hoga, because thermostat is there. It will not allow to change internal energy. Temperature will remain constant. So all the heat absorbed will be used for expansion work. and supposing it releases heat, then surrounding will use all the heat to make compression work. So all heat absorbed or evolved is used for work. And in this case, del H is equal to del U plus del PV, because P and V both are changing if it will be reversible, particularly it is reversible. Isothermal, but again we will make it little more restricted to a reversible process. If it is a reversible process, P changing, V changing, PV remains always constant, Boyle's law. So change of a constant is 0. So del H is equal to del U. So these are all ornamental questions you might ask in isothermal reversible change. What is del H? Is same as del U, because PV remains constant, right? So this is having little physical significance. If it is formed at a variable pressure, then enthalpy will feel bad. अरे मेरे बारे में आप डिस्कस कर रहे हो, लेकिन प्रेशर हमेशा हर इंस्टेंट चेंज हो रहा है, ये क्या है? ये just ornamental discussion. What is the enthalpy change in case of isothermal and reversible expansion or compression? It is same as internal energy change. Right? Then let us go to the next thing, that is adiabatic. Whenever you are expanding or compressing in an insulated container, what is called an isolated system, whether it is expansion or compression, or it is a chemical reaction happening inside an insulated container, that is an isolated system. Because in our classes, guys, we will be discussing both physical and chemical. And physical, two types. One is expansion compression, which is the basis of internal combustion engine, and the other one is the physical change, melting, boiling, condensation, freezing. So these are physical changes and a chemical change. We'll be discussing all aspects. Adiabatic process, whatever may be the process. In that case, again I'm writing the bank balance is equal to INR plus dollar. So what will happen? What change that you, what change in this equation you expect? Yes, anyone from the viewers from direct YouTube? And I am very happy that many guys are watching after, because I am, let me tell you, I am maintaining a very secluded life nowadays, staying most of the time outside India with my children. Now I am at US and also sometime in India, but I am very happy to take online classes through Zoom and teach to a limited number of guys, students who are able to reciprocate with me, give me a bit of joy. I only want to spend time with them at this hour of my life. And I thought, if that is the case, why not it will be expanded to more number of such passionate guys who want to learn a so-called difficult topic. So-called, I'm not saying thermodynamics is a difficult topic. It's a very, very easy topic. Once you understand, make your concept clear, not mug up mechanically.
Sir.
Yes.
Sir, since it is a adiabatic process, there is no heat exchange. So I think Q is 0.
Since it is an adiabatic process, insulation is there, so no heat can come, no heat can go. So Q has to be equal to 0. No heat absorption is possible from outside. No heat evolution can be possible to outside. So then it is reduced to del E is equal to W. So in this particular case, the work done in adiabatic process is path independent because it is equal to another path independent function. Of course, it's changed. So W adiabatic work done is a state function. I told you, usually work done is not a state function. But if some work is done adiabatically inside an insulating container, then that work done is definitely a state function. It is path independent because it is equal to a path independent function. Internal energy, please make it U whenever, because I have a habit of writing E, so I am doing that. I'm changing, but change is not abrupt, it's taking time. So this is path independent. And can you tell me, just think of, don't, those guys who are with me in Zoom, if they feel alienated and cannot communicate with me, I'm sure the other guys who are watching from a distance, they will be also alienated. So you can ask me questions, you can you answer my questions, I can pause, stay for a while, it doesn't matter. It is for you, primarily for you. Don't forget that. I'm extending this benefit to others who will be benefiting from this. It is, yeah, the only difference is that I was using bilingual, using Odia. Time and again I have told to Rudra that you have a habit of listening to English non-stop and also communicate to others in English. That doesn't necessarily mean that I am advising you to hate Odia, the language of this soil from where we are born, our motherland and mother place, not motherland, is Odisha. So we love Odia. The language, it has been honored as one of the languages in international list. You find Odia is coming in YouTube. When asking about language, it is coming. Odia is one of them. We are so proud. But I am deliberately using English for many reasons. Yes. So what I was asking? So what other changes you will notice when, supposing I am talking of simply adiabatic expansion? No chemical change. So it was all insulated. This is insulated, so everything insulated, but is movable piston is there, all insulation. So it expanded from say 1 liter and now it become 10 liter expansion. Then what will happen to the temperature?
Sir, I think
volume?
cooling effect will be shown and internal energy will decrease.
Well, definitely whatever work done, you will be doing at the expense of your own bank balance. You have to do the work by spending your bank balance. So when you are doing the work in chemistry, work done by the system is negative. So you are spending, so your internal energy will decrease. So when internal energy will decrease means temperature will fall and there is a cooling effect. Immediately, if you just put your hand inside, just kidding, you'll find a cooling effect. Once you suddenly expand inside a vacuum, inside an insulator, I'm so sorry. About vacuum, we'll discuss after a bit. Inside an insulator, you'll find a profound cooling effect. So, temperature will decrease, volume will be more. Obviously, expansion, you are doing expansion, this loco possible, people will laugh at this. Expand korcho mane volume definitely will increase. temperature decrease kariba because an internal energy will decrease. And if we compare between final and initial, del U will be negative. Decrease means the change from final minus initial will be negative, no doubt about it. There is a decrease means the change is negative. Final minus initial is the change. And the pressure might change. We don't know what is the temperature condition now. It is lowered. So if temperature is lowered, volume becomes more. Maybe pressure remains same, but pressure might change. We have to find the new temperature, new volume. So immediately what will be the pressure? You have to find P is equal to nRT by V. Might increase, might decrease. We can't say. The pressure might change. You can't say decrease, volume has expanded, so pressure will decrease. You can't say with all authority, you can't say pressure will decrease. Pressure might decrease because the temperature is reduced. The the kinetic energy has reduced, and pressure will mostly decrease. You'll find mostly. Because kinetic energy has reduced, temperature has reduced, means kinetic energy of the gas molecules has reduced. So the surface area is increased, pressure is and force is reduced. So force per unit area will has to decrease. So mostly it will decrease. Similarly, adiabatic expansion में क्या होगा? Sorry, compression में क्या होगा?
Sir, heating and
So when
internal
we
energy
compress,
will rise.
then work done, whatever work is done onto it, it will be straightway going to increase its internal energy. There is no heat, nothing. Heat is not involved here. No heat. So whatever work done that has been done upon it by the surrounding will be increasing its internal energy. अच्छा, अगर internal energy बढ़ जाता है तो क्या होता है?
Sir, heating.
Temperature will
will
increase. There is
also
a heating effect. Volume will decrease. Definitely pressure here, internal energy will increase. Del U will be positive, no doubt. And of course, pressure might change. Pressure will usually increases. Because it will be heated up and the kinetic energy will be more, space will be less, definitely force will be more, unit area, the surface area is less, so usually increases. That means everything will change. Pressure, volume, temperature, all will change in adiabatic process. That is the beauty. All will change. Internal energy will change. Pressure will change. Volume definitely changes. So also temperature. How peculiar is the adiabatic expansion and compression. Then coming to next to isochoric process or isovolumic process, where by some process we keep the volume constant. By anyone, I've told you what are the conditions when volume remains constant. I've told you. So in that case, when we write del E is equal to the rupee plus the dollar, then if delta V, this is equal to minus P del V, when del V remains constant in isovolumic process. So what will happen to the relationship between del E?
Sir, equal to Q.
So the heat absorbed or evolved, we know in a isovolumic process at constant volume process will be responsible only to change in internal energy, hence change in temperature. There will be no change in volume. So tell me, I have a question for you. What other changes will happen? And it follows which law? I mean, ideal gas law. Anyone watching from the YouTube source can tell me what change will happen, just like we found in adiabatic expansion or compression. Every change is happening. Internal energy, volume, temperature, and also pressure. So in this isochoric process, the volume is remaining constant. Either you are using a sealed container or you are handling chemically all liquids and solids where volume change is negligibly small, or del n is equal to 0 even if it is a chemical process. By chance, the number of moles in the reactant side and product side are equal. And in this case, what will happen?
Sir, pressure will increase.
Precisely. If the volume remains constant and the temperature is increasing or decreasing, accordingly, proportionately, the pressure will increase or decrease. Which law? I told you at the end. Very recently, I told you. What? Hamilton's law. Pressure is directly proportional to absolute temperature. So pressure will increase and temperature will increase because internal energy baduchi mane. This is, we can call it isochoric expansion. Isochoric process or change. It can either increase or decrease. If you are continuing to give more and more heat, temperature will become more and more, pressure will become more and more. If you remove the heat, then temperature will be down, so also pressure will be down. I will show you in graph. In the P versus V graph, I will show you how to represent isochoric. Now we are left with isobaric process. This is Hamilton's law. Now coming to isobaric process, where pressure will remain constant. Then enthalpy will become very happy. Oh, I am happy because the enthalpy term has come into force only when the process is carried out at constant pressure. Isobaric. What is C or K? C or K?
C.
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 It's not the title baric. Then if that is constant, then QP is equal to del H or delta E is equal to Q plus E, a Q plus W. So in place of W, we can write Q minus P del V. P is constant. So this QP or simply del E is equal to QP minus P del V. So the whole equation will be valid. And in this case, since pressure is constant here, then what will happen? What are the changes? Which law will govern?
Charles law.
Precisely, Charles' law will govern. So here, if it is expansion, volume, if it is isobaric expansion, volume increases with temperature. With increase in temperature. If it is a compression, then volume decreases with decrease in temperature. And there is no other way out because you are keeping pressure constant. So V is directly proportional to T. P constant. This is Charles' law. Then we will talk about a little bit of, cyclic process, which is important in our journey. We'll be, coming across with so many types of cyclic processes, and that too reversible and irreversible. So in a very broad sense, you start from A, this point, and you are coming to point B, maybe after 2 steps. First, maybe isobaric, then adiabatic, whatever. You are coming to B. And again, you are returning back to A, maybe 2 steps or 3 steps, whatever. This is the forward journey. And this is a cyclic process. In cyclic process, exactly del E, del U is equal to U plus W, and here del U is equal to 0. Just like isothermal process, you are returning back to the same place, same place. So whatever heat you have dissipated, you have got back. So your internal energy is same. If you are returning back to the same state, then your internal energy is same. But W and Q, they are not any properties, thermodynamic properties, they are functions, and they are not also state functions. Maybe I forgot to tell you that individually, I am just writing down in a different place. Individually, Q and W are not state functions, excepting under restricted condition. I forgot to tell you that when we carry out a isovolumic process or isochoric process, so this Q isochoric is a state function. I forgot to tell you, because that is equal to a state function. So adiabatic work done is a state function, path independent. Isochoric heat absorbed or evolved under constant volume is also a state function. That restriction, but not always Q and W are state function. But interestingly, the sum Q plus W is always a state function. Why? Why?
Sir, it is equal to
Because Q
internal
plus
energy,
W
which
is
is a
always
state
equal to
function.
del U. Since U is a state function, the sum of Q and W will be definitely path independent. The sum is a state function. But independently, Q and W are not state functions. Only adiabatic work done is a state function, and isochoric heat transferred is a state function. So coming back to the cyclic process, del U is equal to 0. So it is as good as an isothermal process. So Q is equal to minus W. So whatever heat will be absorbed, and that will be used for performing work, or whatever heat will be evolved, that will be used by the surrounding to perform work on the system. And this is the principle how a cyclic, an internal combustion engine work. It absorbs some net quantity of heat and performs work. That work is in the form of running the motor, and we go. As I've told you, the internal combustion engines are increasingly becoming obsolete. I think by 2050, these fuel-based vehicles will be almost half. All EVs will come up. The hydrogen vehicles will come up. Green hydrogen, I'm talking of green hydrogen vehicles. Nowadays, they're not popular because they're using gray hydrogen or so-called blue hydrogen, which are almost a misnomer. So, with this, we conclude today's session with a note, with an interesting note. You see, well, no, one thing is left out. That is expansion in vacuum. That is important because we will be carrying out the short discussion on the Joule-Thomson effect that we have done. Supposing you have gas here, and here is vacuum. No, nothing. Literally nothing. Here is gas. And you open, there is a small hole, you open it. So it expanding, the gas is expanding to vacuum. There is no pressure. It will expand indefinitely. So during that condition, so when it is expanding in vacuum, this pressure is equal to 0. Vacuum means there is no pressure. When P is equal to 0, the bank balance is equal to rupee plus dollar. That is equal to Q minus P del V. When this P is equal to 0, so this work done is equal to 0. So in this situation, del E is equal to Q, like isochoric process. But supposing it is isothermal. If it is isothermal, brought about in a constant temperature bath or a thermostatic bath, then del E is equal to 0. Hence, Q is equal to 0. Everything becomes 0. If it is adiabatic, carried out in an insulated container, Q is equal to 0. Hence, del E is equal to 0. So, interestingly, whether you are carrying out isothermally, adiabatically, it is. In all the cases, everything will be 0. Del E 0, no change in internal energy, no change in, no heat change. And of course, the pressure is 0 means the volume expansion is happening. The only change that happens is volume, but no change in pressure. Oh, well, when it goes there and occupies a space, then it will create pressure, but it is expanding infinitely. Because pressure 0 means the expansion is vast. So pressure is, it's going to 0 pressure. Later it will develop pressure, it will attain equilibrium. We forget about it. So that is expansion in vacuum. No, I have not told you. Yes, this is the graph, interesting graph. You draw it and we'll close this session. Draw it. This is pressure versus volume graph, mind you. No, I think I will draw. Then I will make a correction, addition. This is P versus V graph, which we have drawn for Boyle's law. And this is our usual Boyle's law graph, ideal condition. This is isothermal and reversible. Whenever you coin the term isothermal, reversible is automatic. Buy one, get one free. That's it. If you carry out isothermally using a constant temperature thermostatic bath, then there is no way that you will do very fast. It has to be slow process and it is an ideal process. And always the adiabatic graph will be falling below the isothermal graph. This is adiabatic graph. And I will ask you why. And of course, when the volume remains constant, the graph will be just looking vertical. It will be isochoric or isovolumic change, not expansion. But these two are expansion. These three, this is isobaric. You are coming from, this volume is constant at V1, isochoric, but you are coming to volume 2. All these are expansions. But here, this isochoric process, there is no expansion, but we call it isochoric process. This is isobaric. Pressure remains constant, but there is a change happening. Charles' law change is happening. Tell me, during this journey, what is changing? Volume is changing, you can see it from the graph. But what internally
V.
changing, which you cannot see in this graph? Yes? Yes? Rudra? Omkar?
T. T.
Kohuno jore
Sir,
temperature.
internal and
Seta mu kohuni. I'm telling what
Temperature.
temperature will change. This is Charles' law. Volume is changing means here throughout, which is not depicted in this graph because it's a PV graph. But temperature is increasing, volume is increasing, means it is due to increase in temperature. Temperature increase is the cause and the effect is change in volume, increase in volume. And if you are compressing, going in this direction, so you are getting compression or reducing the volume, the pressure is remaining constant, it is due to decrease in temperature. Now what will be happening during this journey? This is not expansion nor compression, but this journey, this change that has happened with the reduction in pressure. Pressure has reduced from P1, say for supposing P1 to P2. So what might be happening? How the pressure is reducing?
sir,
How the pressure is?
changing.
Yes.
Sir, temperature, sir, it is cooling.
Yes, temperature is coming down. The pressure is decreasing because you are decreasing the temperature. You are cooling. The cause is cooling, reducing the temperature. The effect is a decrease in pressure because you are keeping volume constant. And if you are going in the opposite direction, you are going in an opposite direction, then the temperature is increasing. That is why pressure is increasing because the volume is constant. Understand?
Yes, sir.
Yes, sir. Yes.
Now, from the concept of integration, from the concept of the area bound by the graph to find the total work done, say from V1 to V2, which will involve more work? Isobaric, carried out at constant high pressure, because this is not the pressure we did. Isobaric expansion occurred at a lower pressure. We started this, we took this small rectangle we take. No, I am saying the same pressure. This is a comparison starting from the same pressure, constant pressure in case of isobaric, and some same pressure to the reduced pressure in isothermal. So also another reduced pressure in in adiabatic. So whose work done will be more?
Isobaric.
Sir,
Isobaric.
isobaric.
I am not considering the case that I discussed before, that 10 kg is replaced by 1 kg, then 1 kg is the external pressure. Here I am taking the same starting pressure. So isobaric work done is the greatest, followed by
Isothermal.
Isothermal.
Reversible.
followed by
Adiabatic.
Adiabatic.
and zero का
Isochoric.
Isochoric.
अर्थात तो जीरो, इसका जीरो है तो इसका लिखने से कुछ फायदा नहीं है. वर्क डन इज जीरो बिकॉज अदर एरिया नहीं है, सीधा सीधा भीतर तो किसी एरिया नहीं, जीरो. Now my last question is why the work done in isothermal process is greater than that in adiabatic process. And the follow-up question will be why the adiabatic graph always remains below the isothermal graph. Yes. Believe me, the quantum of my experience that I will be putting in these classes, I guess, I firmly guess you will hardly find anywhere in any book, in any literature. It will be more of, stereotyped kind of information that you will get, not a feel what is happening really.
In adiabatic, the rate of change will be more.
Rate kotha eti kinetics kotha ase, nothing to do with rate.
Uh,
Yes, Rudra. Why the graph runs below? Adiabatic graph runs below isothermal.
sir, adiabatic रे
Sir,
किसी sir, in adiabatic process there is no heat change. So, or and in isothermal process, mm,
No, I'm not
Q.
convinced. I'm not happy with your answer. Priyani, we wanted to say something?
Sir, adiabatic occurs in changing of temperature,
Precisely.
while isothermal
Okay,
thermal,
that's all.
occurs in constant.
That is, Priyani, the only reason why you are with me. You are with me. It is the only reason because you have a fantastic understanding power. I will not talk anything more because here it is a class meant for public, I mean all. Because now see Omkar and Rudra, that supposing you make the volume fixed, you consider this point and this point where the volume is fixed for the adiabatic and isothermal. Because at a given volume, for isothermal temperature is fixed, but for adiabatic, since it is expansion, temperature is less. For isothermal, temperature is constant throughout by using a thermostatic bath, but here this is less. So when the temperature is less, the volume has to be less. The pressure has to be less. Hamilton's law, because volume is kept constant here. Therefore, since the temperature is less, the corresponding pressure is less than the isothermal value. Are you following me?
Yes, sir.
Yes, sir.
Or you can use the other way. Oh my God. You can use the other way. You can take a fixed pressure and use Charles' law. You compare this point and this point, where the pressure is fixed. And since the temperature here is constant, here the temperature is less because it is adiabatic. The temperature is less. Expansion is happening, and here is expansion, here it is expansion. Volume is changing. Maybe small change, maybe bigger change. But since volume is expanding, there is a decrease in temperature, but isothermal, there is no change in temperature. So when this temperature is decreasing, the pressure is decreasing. So temperature is decreasing, volume is decreasing. Therefore, it has got a lower volume. You understand? This has a larger volume, this has a lower volume because pressure is kept constant. You use the Charles law, since the temperature is less here, the volume is less. Temperature is more here. More means is constant and more. This is less. So this is volume is more. You understand now why the adiabatic
Yes.
graph will always run below the isothermal graph? Because of the
Yes,
change in
sir.
temperature. Expansion is happening, temperature is falling down. And if you go in the reverse direction also, you will find heating will be there and the corresponding pressure will be more or volume will be more, the other way around. Understand?
Yes,
Yes,
sir.
sir.
So that is all. And one little thing I forgot to tell you, just for a formality, in adiabatic process, in the temperature is changing, we always say del H. People ask, is del U how to correlate with P del V? Del V, because number of moles is not changing in adiabatic expansion or compression. So PV, if V is changing, it is due to the change in temperature, is nothing due to the change in pressure. So we approximately write del U minus NR delta T to find the correlate between when everything is changing, enthalpy change carries no meaning, but still you get a question. When we discuss about the heat capacities Cp and Cv, then we'll have another relationship. So we can find out what is the enthalpy change is happening. And what is enthalpy change? Pressure is changing. You are asked a question. Then you will use, because number of moles is not changing, R is not changing. So P del V ke badle mein you will write del NR delta T. The same thing, in this case, isochoric process, del H is equal to del E, because volume is constant means del V is constant. So same change in internal energy, same as change in enthalpy. It carries little meaning. Okay, but people ask, but here del H is equal to del U plus a minus P del V. So again, here also temperature is changing. Just like adiabatic, you will also say del U minus NR delta T. So here delta T will be taken into account. Only in chemical process, you take del N, the number of moles, and where that is carried out at constant pressure, T remains constant, you take del N. In all physical processes, number of moles remains the same. It is either the temperature difference, or no temperature difference in isothermal. No temperature difference, del H is equal to del U. In isochoric, del H is equal to del U. And in adiabatic and isobaric, del H is equal to del U minus NR delta T. Clear hai?
Yes, sir.
sir.
With this, we conclude. It is already 2 hours past, 7 minutes past 2 hours. And I'm sorry that I could not keep my word to have 1 hour class today. It became more than 2 hours. Sami, you please make up. And if at all you have any doubt, feel free to tell me. I will have separate session to explain to you. Bye-bye. Bye, guys who are watching from outside. And don't forget to show your generosity by hitting the subscribe button. I'm almost sure that you like it. You are liking it. I'm almost sure, because my inner self will say, my inner self is saying that if you are really a good guy means you are an intelligent guy, because I'm telling so many things in a short time. So you are able to understand and enjoy it. So why not? Why you become so miser not to hit the subscribe button? Hit the subscribe button, also the like button. Bye bye.
Bye, sir.
પ્રિયાની તમે કોડ થી લો અયો
Sir, update ହେଲା Zoom ତ ସେଥିପାଇଁ time.
ନାଇଁ ନାଇଁ ଆଉ ଗୋଟେ କ୍ଲାସ୍ ତ କାହାକୁ ଯାଇଥିଲ ଆଉ ଗୋଟେ କ୍ଲାସ୍ କୁଆଡେ ଥିଲ
Sir, କାଲିର ଯୋଉ class ଟା ସେଇଟା ମୋର tuition ଥିଲା ସେତେବେଳେ.
କାଲିକା କଣ
Sir, କାଲି ଆପଣ ଯୋଉ live session ଟା